Hello student. Today I am going to discuss about linear conservation of momentum. Topic of physics class 9. In the case of linear conservation of momentum, dear student, it means that when any two objects collides with each other, then sum of their momentum before collision and after collision remains constant. When any two objects, suppose that this is first object A and second object B, mass of first object is m1 and its velocity is u1. Mass of second object is m2 and velocity is u2. After collision, velocity changes. Both the object changes its velocity. Velocity of first is v1 and second is v2. In this case, according to the theorem of this linear conservation of momentum, means when any two objects collides with each other, then sum of their momentum before collision and after collision remains constant. According to definition of momentum, we know that momentum means product of mass and velocity. In this case, mass is m1, velocity is u1, so its momentum is m1 u1, and momentum of second object is m2 u2. So sum of momentum of both the objects is m1 u1 plus m2 u2. And after collision, velocity of first object is v1 and velocity of second object is v2. So sum of their momentum is m1 v1, momentum of first, plus m2 v2, momentum of second. Today we will prove this formula with the help of force. Dear students, we are going to prove linear conservation momentum, formula of linear conservation of momentum. In this case, m1 is mass of first object, m1 is mass of first object, and m2 is mass of second object. Mass of second object. And after that, u1 is velocity of first object. u1 is velocity of first object, and u2 is velocity of second object. Velocity of second object. This is velocity of first. u1 is velocity of first object before collision, and u2 is velocity of second object before collision. In this case, dear students, when any two objects collides with each other, these conditions of both the objects is before collision, and this when both the objects interact with each other, collide with each other, and after collision, velocity changes. Velocity of first object is v1 and velocity of second object is v2. According to theorem, we have to prove sum of their momentum before collision and after collision remains constant. According to this, in the condition of collision, first objects collide with second object. It means that first object will force to second objects, and second will also push the first object. According to third law of motion. According to third law of motion means action reaction. Every action there is always equal and opposite reactions. So in this case, first objects applied force to second object means first FAB, force exerted by A to B, and second object will force same force to first object means FBA in opposite direction. According to law of action reactions, every actions there is always equal and opposite reaction. It means that FAB, force exerted by first object to second object, will be equal to force exerted by second object on first object. But we know that according to third law of motion, every action there is always equal and opposite reaction. So since opposite reaction, so here should be sign of minus. Now we will prove, dear students, we are going to proof of linear conservation of momentum. It should be FAB should be minus of FBA. Minus sign here, minus sign indicating that force applied by first object on second object should be equal to force applied by second object on first object, but direction of both the objects is opposite, so FAB is equal to FBA. Now since we know that force is equal to mass into acceleration, and acceleration means changes in velocity. In the place of acceleration we will put v minus u upon t. Now listen carefully. Force applied by first object on second should be force is equal to mass of first object, that is equal to m1 into acceleration, that is equal to minus force applied by second object, mass of second object is equal to m2 into acceleration. Now m1 into, in the place of acceleration we can write change in velocity v minus u. In the place of acceleration we can write v minus u. Initial velocity of the object m1 is u and final velocity is v. So in the place of acceleration we can write v1 minus u1 upon time. After that minus m2 into, in the place of acceleration by second object, final velocity of the second object is v2 minus initial velocity of the second object is u2 whole upon t. Denominator should be cancelled by denominator, so t and t cancel. Now we will multiply, we have m1 v1 minus m1 u1, that is equal to, we will multiply by minus of m2, that is equal to minus m2 v2 plus m2 u2 minus m2 v2 plus, now we will separate the terms. Values related to v1 should be in one side and values related to u1 and u2 should be in another side. Now we can write m1 v1 minus of m2 v2 in left hand side should be plus of m2 v2, that is equal to plus of m1 u1 plus m2 u2. This is the proof of linear conservation of momentum. m1 v1 plus m2 v2 is equal to m1 u1 plus m2 v2. In the place of this we can write m1 u1 plus m2 u2, that is equal to m1 v1 plus m2 v2. Yes students, this is the proof of linear conservation of momentum. According to linear conservation of momentum, we have to prove sum of linear momentum before collision both the objects. Sum of linear momentum of first one is m1 u1 and momentum of second is m2 u2 before collision. The sum is m1 u1 plus m2 u2. After collision, momentum is momentum of the first objects m1 v1 and momentum of second is m2 v2. Sum of both is m1 v1 plus m2 v2. In this case, we can prove this for common velocity. In the case of common velocity means when any two objects collides with each other and after collision they combine and travel together. To calculate common velocity, in the place of v1 and v2 we put only value v. Yes students, for common velocity formula is m1 u1 plus m2 u2, after that m1v plus m2v. To solve numericals related to common velocity means when any two objects collide with each other and after collision they traverse together. In this case, common velocity v is common, m1 plus m2. To calculate common velocity we can write v is equal to m1 u1 plus m2 u2 whole upon m1 plus m2. This is the formula of common velocity in the case of linear conservation of momentum. Dear student, in next video we will discuss about numerical of linear conservation of momentum. Thank you.